Hello everyone. Welcome and thank you for coming. People come to such presentations for different reasons. If you feel budget cuts, pressure, and you came for a miracle, this might be the right place for you. If you are looking for your personal skills upgrade to stay competitive in this market, you are looking in the right direction. Anyway, if you're related to information technology, this presentation gives you something very important to think about. What can you expect from this presentation? You will learn about the upcoming changes in IT. This presentation helps you better understand, get ready, and embrace these exciting changes. It is time to reposition yourself and your company in this quickly changing market while cutting costs and gaining efficiency. And what is not there? Do we promote any vendor? No. Our motto is minimize the number of vendors and licenses. Do we expect you to completely rely on consultants? Absolutely not. Increasing efficiency and knowledge and becoming a leader in your area is an intimate business of your company, although consultants can help you getting started. Now, what does it mean, getting started? Two things. Number one, planting the seeds of innovations in the existing business ground. And number two is establishing a self-sustaining process of growing new skills and gradual transitioning to the IT of the future. My name is Jeff Zhuk. I'm an enterprise architect and a knowledge engineer. In the late 90s and in the beginning of this century, I promoted the vision of services. At the Java 1 conferences and in my book, Integration Ready Architecture and Design, I talked about the new ways of creating applications. Business analysts would just create a new combination of existing services and hoopla, a new application is ready for work. No projects and no project managers. And I believed in what I talked about, and I was not alone. We created thousands and thousands of services, and we brought service-oriented architecture, SOA, to the new level. Only from this level, the enormous gap between the services and business applications became visible. It is like getting to a mountain summit only to realize that this was a false summit, but there was no other way to see the real one. Business and technical people don't always understand each other, and this might be understatement. While technology speaks XML and web services, business prefers natural language. Translation from business to technology is called the development process. Cooking an application involves several translation layers and teams. We're still jumping through the same hoops after we have developed multiple services and promoted service-oriented architecture, after we've invested in the enterprise service bus, business modeling tools, and more. Don't take me wrong, I'm for SOA. SOA saves budgets, and for bigger companies, the savings are bigger. But to fully benefit from SOA, we need to give subject matter experts the keys to business architecture. We need to bridge the gap between business language and the services. Just imagine that a business analyst writes a line of requirements or just says the application starts with a login. This sentence comes to a program that scans all existing services and finds a possible match. The program makes no assumptions. It comes back to you with the question, do you mean the authentication service? And business analyst would confirm, and the computer would ask, what roles and privileges do you have in mind for your users? This friendly dialogue will lead to building a working application on the fly. This is a cross-section of two approaches. First of all, it is a conversational approach. We engage a subject matter expert in an active conversation with the computer. Ideally, Both may get smarter in the process. But we know that no computer can understand unexpected business terminology. It is not XML described by the schema. Here is the semantic approach, the second approach, which would use a rich dictionary formatted as ontology to better understand business language. I started working on this bridge a decade ago, have several patents and publications, and many really brilliant people contributed to this area of integrated knowledge and software engineering. And the whole industry started turning its heavy wheels. Yes, the industry started turning this direction, and enterprise IT, as we know today, is slowly disappearing. Some companies are transitioning their IT to a cloud, but a much bigger transformation is on the way. Different types of information were historically present by different systems, creating enormous complexity and budgets, paying for multiple vendor licenses and skills. This is going to be a history. Some companies already started transitioning to a much simpler, unified platform. Department of Defense is under tremendous pressure for budget cuts. Denis Wisnowski, CTO and chief architect of DoD, projected about 50% of IT saving by transitioning to the new architecture based on big data and semantic technologies. Let us take a closer look at the current situation. We have data silos and duplications, different data formats and multiple APIs, missing integrated business view. In the bottom line, it is complex and expensive and not efficient. Big data and semantic technology is changing IT by offering a unified landscape for all types of information. Till now, we only used a small fraction of knowledge power available to us. About 10% of the corporate knowledge is stored in the databases. These data are actively used by our applications. About 20% of our knowledge is in the corporate files and folders as instructions and regulations for people, the readers. And about 70% is the tribal knowledge never captured electronically. We can do this today. Semantic technology products can transform unstructured data into a structured form called ontologist. Or we grow this data into linked data. Google's original ideas of a big table has transformed into what we currently call the big data industry. Think of a huge table where you can throw any data, and you still can link all this data in a similar way how we link different concepts in the natural language. Wait a minute. Did I say one table? Any DBA, database administrator, tells you that this is not efficient. Specific data tables in specific applications make specific SQL queries perform faster. True. But in the increasingly interconnected business, these data that belong to many different departments must be integrated, and integration efforts outweigh the benefits of specific approaches to specific data. A growing art and science of big data helps us to deal with the growing ocean of information, absorbing a full story, not just separate pieces. The mix of big data and semantic technologies is the perfect mix for a cloud infrastructure. Just think about it. If we move to the cloud, multiple platforms currently supporting our applications, the benefits from the cloud are really questionable. A unified platform in the cloud makes the cloud infrastructure cost-effective. And this unified platform is ready for intelligent analytics. The benefits are clear: cost, efficiency, and unprecedented power of knowledge understood by people and machines. Now, how to get there in a safe manner with very practical baby steps and with minimum upfront investment? You will conduct analysis and select your pilot projects in which you do the following starting steps: standardize business processing, place the seeds of big data, cloud, and semantic technologies in the current business ground, and establish a self-sustaining gradual transformation process. This transformation focuses on information. Connecting many types of information is impossible without collaborative work. Big companies usually have data governance and other governance organizations that are supposed to serve this purpose. For this project, you will need the information governance, a new type of umbrella organization. This shall be a very modular and flexible organization to lead and accelerate the transformation process. I'd like to notice that not all governance organizations properly play this role. Start small and focus on establishing self-sustaining, growing training where a small group of people would obtain the necessary skills to immediately apply in specific domain areas for tangible budget saving. And then the students would become the trainers, and the trainers will teach the trainers. The major goals for the training: engage small groups in 2-3 collaborative pilot projects, to minimize number of vendor licenses and transition to cloud-based simplified infrastructure, integrate structured and unstructured data into the knowledge warehouse, and support decision-making processes with knowledge-driven conversational services. I talked about several things like knowledge, ontology, that I feel that I need to step back and provide some background. If you agree with Sir Francis Bacon that knowledge is power, it must be no surprise for you that there is a science of handling knowledge. The name of this science is ontology or knowledge engineering. The same word ontology also means a computerized collection of related facts and terms. Semantics is a study of meaning. Semantic technology offers the tools helping to understand the meaning of information, helping to transfer unstructured text into the rich, structured ontology models understood by computers. This might be a good point to discuss the difference between taxonomy and ontology. Taxonomy collects the keywords to describe content. Ontology uses more powerful methods to create much richer metadata models. Besides collecting the key vocabulary, ontology picks up the relationships between the keywords, effectively building semantically rich, much more meaningful model of the content. Let's say we have a sentence: Jeff Zhuk was born in Russia. Taxonomy takes two keywords from the sentence, the name and the place. Ontology would also add the relationships and creates a graph, which represents the content in a more complete fashion. This graph can be extended and later used for querying, in other words, for asking questions related to this information. We are almost there. Now let's stretch, leap and spin and we can talk about creating a corporate knowledge warehouse. Several knowledge domain modules formatted as ontologies and integrated together create a corporate knowledge warehouse. The knowledge warehouse can be built gradually in the daily interactions with subject matter experts with a conversational interface. Each interaction will work in both directions, helping the subject matter expert and contributing to the knowledge modules. I hope you still remember my previous slide about the conversation between subject matter expert and a machine. Let's take a closer look at this example. We focus here on the conversational decision support in application development. A business analyst writes a line of requirements. Application starts with login. And the service would reply, "Do you mean the authentication service?" A decision has to be made by a person, not a machine, while the machine would take all the boring parts of this work. It will scan the branches of the knowledge trees and map people's sentences to the terms and formats understood by computers. The magic of big data and semantic technology saves development time and significantly cuts the budget. Here's an example. Lost in translation is a very common case in software development. Let's take a look at the creating the model. Creating the model is one of the first phases of the translation requirements into a working application. The model is the blueprint we follow while building the application. Only in the latest cycle of the development, our testing process can validate the model and result in application. At this point, each lost and found item is extremely expensive. When 100 pages of requirements are extended by many other documents, industry standards, and regulations, it is close to impossible to verify if the model is compliant, unless we start using the magic of semantic technologies and big data. Computerized help is highly appreciated here. We do not expect everything done by a program, but a lot of subjects in the requirements can be automatically verified and others can be displayed as red flags for manual verification. On the slide, two processes start from the same set of the documents. On the left side, system architects create a model. In this example, it is a business process model. Then we can convert this model into a semantic graph. On the right side, big data and semantic tools create a semantic model based on the same documents, just strictly from the requirements and regulations. Then we can compare these two semantic graphs to find mismatches and violations. The benefits of early findings and early corrections are dramatic. Usually, disconnects are found at the very end of the development cycle during the system test. At this point, redesign and redevelopment is very expensive, and the alternative is to move the disconnected points into another project. Business does not like it and tend to change horses looking for contractors. The magic of big data and semantic technology can be included in the current development process to cut development costs with early diagnostics. This is the first step towards the new development model, conversational development. Some elements in the process of the translation of requirements into an application will be done by a computer with subject matter expert participation. Subject matter expert here is an architect and developer. This will further cut budget and add efficiency to the development process. The smartest companies already started this transition. It is time to catch up. Yes, it is about the new skills and IT is upgrading their skills. The companies which started this process earlier are becoming the leaders in their business domains. The example is a British BBC, the media company, or the international company AM Docs. It is number one today in the telecommunications. The time is right. There are many tools and related tutorials helping to cover the gap between complex realities of the current enterprise infrastructure and semantic cloud architecture. Any person, even slightly related to IT, has to learn or upgrade the following skills. It is about service-oriented architecture and the clouds, big data and semantic technology. The book IT of the Future, Semantic Cloud Architecture. This book offers an integrated view on these major areas. This book starts with a theory and continues with a very practical transitioning baby steps, including the architecture, pilot projects, and code samples. An essential part of the book is dedicated to creating an implementation playground. The Business Architecture Sandbox for Enterprise, or BASE. The BASE is a set of tools created by the author and offered free with the book to facilitate collaborative training and experimentation in this relatively new technology field. Built in the book, the message from 2044 shows several layers of technology and society in the nearest future, evolving economy and new competition and collaborative forces. Start moving to more efficient IT today, and if you need help, I will be happy to help you. I wrote a couple of books and several articles on the subject and developed a library of transitioning tools. I call it Business Architecture Sandbox for Enterprise, or BASE. BASE is well described in my second book, where I also wrote about the basic ideas and approaches for the transition. There are patented examples of implementations for some of the ideas. For example, knowledge-driven architecture. The idea was simple. For many years I wrote software applications and I taught others how to do this. The most important part is in the definitions of business rules and scenarios. This part usually served us as a starting point for multiple layers of translations by developers. The knowledge-driven architecture describes a solution where properly captured business rules and scenarios directly drive the application. No development project for further translation is needed. Or the adaptive robot system with a knowledge-driven architecture. Current robotic systems are programmed upfront to perform relatively simple, well-defined and predictable tasks. This invention integrates software and knowledge engineering with robotics technology to create a platform for intelligent multi-robot systems that could share tasks and data and, if necessary, converse with people while translating situational task requirements into adaptive behavior models. And this is not just an idea anymore. The patent format requires to provide at least one specific construction to implement the idea. Yes, the industry is moving and moving fast. I wish you good luck in your transitioning to the IT of the future. Our contact information is below. Do not hesitate to write us, and thank you for attending this event.